The room is quiet now, and somewhere far from your bed, a lantern hums in an old mine. Dust hangs in the air like slow snow, and every footstep lands soft on stone. You can almost taste it, that faint, metallic dryness that clings to the back of the throat. In the dark, something catches the lamplight and moves like a living bead. Quicksilver, Mercury, heavy as regret, bright as a tiny mirror, rolling wherever gravity feels like pulling it. Tonight, with the Sleepless Scientist keeping watch, you are not here to panic. You are here to observe, gently, patiently, why this strange metal was worth the trouble, and why the real danger was never the rock, it was the air. You think you are here for treasure, for the dramatic crack of pickaxes, and the satisfying moment when the stone finally gives up something valuable. But that is the fairy tale version. Down here, value is measured in what you can carry and what you can survive breathing. The miner ahead of you lifts the lantern a little higher. The flame trembles, not from romance, but from hunger. It is eating oxygen quietly, constantly, like a small animal you have to keep alive. The air feels warm in a way that does not belong tonight. It is a wrapped blanket kind of warm, the kind that makes your skin slightly damp, even when you are standing still. And there it is again, Mercury. A bead, then a smear, then a small gathering of shining drops, caught in a groove in the rock. It does not soak in. It does not politely spread out like water. It keeps itself together, proud and tense, like it refuses to touch anything it does not respect. That is part of its charm. Mercury is a metal that behaves like a liquid at ordinary temperatures. You do not have to melt it with a furnace to watch it flow. It just does. It rolls and merges and splits again, always shiny, always heavy. If you nudge a droplet with the tip of a tool, it glides away as if it has opinions. People wanted it for reasons that, up close, feel almost boring. Not evil, not mystical, just useful. If you have gold locked inside crushed rock, Mercury can help you coax it out. The gold dissolves into Mercury, forming an amalgam, an intimate little partnership that makes the gold easier to gather. Later, you heat the amalgam, the mercury leaves as vapor, and the gold stays behind. Congratulations! You have purified gold and also filled the air with something that does not forgive lungs. Mercury was also a way to make bright color. The deep red pigment called vermilion comes from mercury sulfide, a mineral with the charming name cinnabar. You grind it, you mix it, you paint with it. It looks like life, like blood, and sunsets, except it is made from something that does not care about your life at all. And then there were the old medicines. Those deserve a slow blink. For a long time, people believed mercury could chase illness out of the body. Sometimes they rubbed it on skin. Sometimes they swallowed compounds made from it. Sometimes they sat in rooms where it was heated, letting the vapor drift into their mouths and noses. The goal was cure. The result was often a different problem wearing the mask of progress. Down here, though, the medicine is simpler. You work, you sweat, you cough, you rest when you can, you eat something dry and salty, you drink water that tastes faintly of the container, you go back underground again, because work is work, and the rent does not care about chemistry. The mine has the obvious dangers first. Low ceilings that force your neck into a permanent apology. Stone that flakes without warning. Tools that bite fingers when hands get tired. Hours that stretch out until your mind forgets what daylight feels like. And always that taste, metal on the tongue, as if the air itself is made of worn coins. But the mind is also a teacher. It teaches you that the most dangerous thing is often quiet. It does not fall from the ceiling. It does not scream. It simply accumulates. And as your eyes adjust to the dark, you start noticing the real problem isn't the rock at all. It's the air you're breathing. The strange thing about Mercury is that it can leave without you seeing it go. It can become vapor, an invisible gas, especially when it is warmed. You do not need a roaring fire. You do not need a dramatic accident. You just need enough warmth, enough surface area, enough time. The droplets you saw, those bright, satisfying beads, are only the part Mercury allows you to admire. The rest of it can slip into the air, molecule by molecule, until the mind holds a faint, poisonous fog that looks exactly like nothing. You are breathing it in now, not because you are reckless, but because you are human. Your lungs are built to be generous. They are not picky. They are a wet, branching forest designed to pull oxygen out of the air as efficiently as possible. They do not ask permission. They do not run background checks. Each breath draws air down into smaller and smaller passages until it reaches the alveoli, tiny sacs where gas meets blood. The wall between them is thin on purpose, because oxygen has to cross fast. That design is brilliant for staying alive. It is also extremely convenient for anything else that wants inside. Mercury vapor is one of those things. It passes into the bloodstream and begins traveling, like a passenger who did not buy a ticket. And at first, you may not notice. That is the cruel part. The body can take small hits and keep walking. It can balance and compensate, like a tired worker shifting weight from one aching foot to the other. Small exposures add up, not always in a neat, obvious way. More like dust settling on a shelf. You do not see it building until you wipe your finger across the surface and realize how long it has been there. Early warning signs can be plain, the kind you would blame on bad sleep and long hours. You feel tired in a deeper way than usual. Your head aches, dull and persistent. Your mood frays, not dramatically, just slightly shorter temper, slightly heavier thoughts. Your hands might start to tremble, small shakes that come and go. That trembling has a name in old workplace stories: hatter's shakes, because hat makers were once exposed to mercury compounds used in processing felt. The phrase "mad as a hatter" did not come from nowhere. It came from people watching someone change, slowly, under the weight of a job. And sleep. Yes, sleep can become strange, not because the mind is haunted, although it can feel that way, but because the brain is sensitive, and mercury can interfere with it. You might lie down exhausted and still feel restless. You might wake too early or drift into uneasy dreams. Congratulations, even your rest has become another part of the workplace. The sad irony is soft and steady. Mercury was mined to make things more effective. Gold extraction, pigments, instruments, medicines. It helped people measure and manufacture and decorate. And all the while, it quietly made the miners and the workers downstream less well. Not everyone suffered the same. Bodies differ, ventilation differs, luck differs, but the pattern was there, like a smudge on the page that keeps reappearing no matter how many times you turn it. So you start to think like a cautious animal. You watch the flame of the lantern because it tells you something about air. You notice the way heat lingers in certain tunnels. You notice where moisture collects, where walls sweat. You listen for coughs because a cough in a mine is not just a cough, it is a message. And once you realize the air can carry danger, you start thinking about the rest of the body, how it tries patiently to clean up the mess. Your body is not a hero. It is a maintenance crew that never clocks out. Start with the liver. It sits under your ribs, heavy and quiet, filtering blood that comes in rich with whatever you have eaten, inhaled, or absorbed. It is a chemical factory with a calm demeanor. It takes substances and modifies them, sometimes making them safer, sometimes preparing them to be removed. It does this without ceremony and without asking whether you deserve the exposure. Then the kidneys, two steady filters straining your blood all day and all night. They decide what stays and what goes. They regulate water and salts and acid levels. They keep your internal ocean from turning into soup. Some substances are easy to flush out. They dissolve in water. They get packaged up. They leave. Others are stubborn. They hide in fat. They bind to proteins. They stick to tissues like burrs on cloth. Mercury can be especially complicated because it comes in different forms. Elemental mercury, the shiny liquid, behaves one way. Inorganic mercury compounds behave another. Organic forms, like methyl mercury, behave in ways that are even more insidious in living systems. The chemistry changes how it moves, how it lingers, and what it damages. But even without sorting every category, the theme is simple. Your body tries to manage an intruder using tools meant for ordinary life. It can do a lot. It cannot do everything. The brain, in particular, is delicate. It does not like chemical surprises. It is not built to be exposed to heavy metals that can interfere with nerve signaling. Your neurons depend on carefully controlled ions and tiny electrical shifts. They work because the environment is stable. When something like mercury enters the picture, stability becomes harder to maintain. The brain is also protected by the blood-brain barrier, a selective wall of cells that tries to keep certain things out. It is like a bouncer with a strict list. But mercury vapor can cross, and some forms of mercury can sneak through in other ways. Once inside, the brain is not quick to forgive, and still the body keeps going. Breath in, breath out, not as an exercise, just as a fact. While you lie in bed, your organs keep adjusting. Your lungs exchange gases. Your liver sorts molecules. Your kidneys filter. Your heart pushes everything along like a quiet machine that never got the memo about weekends. If you want a comforting thought, it is this: humans survive by maintenance, not by perfection. The body is not clean and pristine. It is a working system in a dirty world, constantly balancing, constantly repairing small failures before they become large ones. In the mine, you can almost feel that endurance. The miner wipes sweat from his brow, leaving a streak of gray mud. He drinks water and keeps walking. He breathes air that should not be breathed and still makes it to the surface, because bodies are stubborn like that. But endurance has limits, and the mind has other ways to test you. And speaking of what the body absorbs, there's another kind of exposure miners never escaped. The slow, gritty invasion of dust. Dust in a mine is not a single thing. It is a family of tiny particles, each with its own history. Some of it is crushed stone, sharp and pale. Some of it is soot from lamps and fires, soft and dark. Some of it is dried mud that became powder again. Some of it is flecks of whatever mineral you were chasing, ground smaller and smaller until it becomes airborne. It settles on everything: hair, eyelashes, lips. It mixes with sweat and becomes a paste that dries into a crust. It falls into food. It hides in folds of clothing. It gathers in the corners where boots do not reach. In lantern light, it floats like slow snowfall, drifting with every movement. You breathe it because it is everywhere, and because you cannot hold your breath for a shift that lasts longer than your patience. The biggest particles get caught in your nose and throat. That is part of the design. Hairs, mucus, the sticky traps that keep large debris out. You swallow some of it without noticing. Your stomach accepts it with weary resignation. But the smallest particles, fine dust, can get deeper. They can reach the small airways, and some can make it all the way to the alveoli. There, your body has other defenses. Immune cells called macrophages patrol the surfaces, looking for intruders. They engulf particles and try to remove them. It sounds tidy until you realize the workload. In a dusty mine, the lungs are cleaning constantly, and sometimes the dust arrives faster than it can be cleared. Irritation builds. Inflammation becomes a background hum. Breathing can start to feel heavier over time, as if the air has thickened. Some dusts are worse than others. Silica dust from certain rocks can scar lung tissue. Coal dust can accumulate. Smoke particles carry their own chemistry. You do not need to memorize names to understand the pattern. Small things, repeated, can become big problems, and the harm is often quiet. There is no dramatic moment when you inhale the wrong particle and collapse. Instead, you cough a little more. You wheeze after exertion. You recover slower from colds. You chalk it up to age or fatigue or the general unfairness of life. The mind encourages that kind of thinking. It normalizes discomfort. When everyone coughs, coughing feels ordinary. When everyone's hands are cracked and blackened, you stop noticing your own. Even the lamps contribute. In older mines, lamps burned oil or tallow, and later, other fuels. Any flame in a confined space eats oxygen and produces smoke and gases. Ventilation matters, but ventilation is not always generous. Sometimes it is a shaft and a hope. Sometimes it is a draft that only reaches certain tunnels. Sometimes it is nothing at all, and the air becomes stale, warmed by bodies and rock. The most harmful things are often the ones you barely notice. That is the gentle reality check the mind offers. It does not kill you with drama. It wears you down with routine. And still, everything settles eventually. Dust on the floor, dust on shoulders, tiredness in the bones. The shift ends not with triumph, but with a slow climb back toward air that tastes less like stone. You emerge into night, blinking at stars that look too clean to be real. The town is quiet. A few windows glow. Someone laughs faintly somewhere, the sound carried thinly in the cool air. You wash your face in a basin, and the water turns gray. You eat, you sit, you feel your lungs working, and you realize they have been working hard for you. In the quiet after the coughing stops, your mind drifts to why anyone did this at all. What Mercury was used for once it left the mine. When you picture Mercury above ground, it looks almost elegant. A silvery liquid in a glass container, a smooth bead rolling across a table in an old classroom demonstration, back when people thought that was a clever idea. A thin line inside a thermometer, rising and falling with heat, translating warmth into measurement. Mercury's charm is physical. It is dense, so it feels heavier than it should when you hold a small amount. It is reflective, so it catches light and gives it back. It resists mixing, so it keeps its shape, like a living thing that refuses to be flattened. It also forms amalgams with several metals. Gold and mercury, silver and mercury, even other combinations. That ability made it useful in mining and metalwork. If you are trying to gather precious metal from crushed ore, Mercury acts like a collector. It pulls the valuable material into itself, making a lump you can separate from the rest. But the process has a cost, and the cost often traveled invisibly. Heating amalgam releases mercury vapor. In small workshops and mining camps, that vapor could spread through rooms and linger. People might have thought they were watching money appear from rock. What they were also doing was letting a heavy metal wander into their bodies, one breath at a time. Then there is vermilion again, that bright red that shows up in art, decoration, and lacquerware. It is a color that looks warm and alive. It is also a reminder that beauty is not obligated to be safe. Nature does not label things for you. Humans had to learn, slowly, that some pigments are not just pigments. Mercury found its way into mirrors too, in older methods, and into electrical switches and relays, because it conducts electricity and flows into place. It became part of instruments that needed reliable contact. It slid into the quiet infrastructure of technology, doing its job without asking if the people handling it had gloves. And then, hat making. The story is almost too perfect, like a moral lesson someone invented. Except it was real. In the process of making felt hats, workers used mercury nitrate to treat animal fur, helping it mat together. The workers handled it, breathed it, worked around it. Over time, some developed tremors, irritability, mood changes, and cognitive problems. The public saw the behavior and mocked it because humans love to turn suffering into a phrase, mad as a hatter. It sounds whimsical. It was an occupational hazard. There is a pattern here that repeats across industries and centuries. Humans try things first. We use what works. We scale it up. We put it in products. We build livelihoods on it. And only later, sometimes much later, we notice the hidden costs written in bodies, not because people were stupid, because the human nervous system does not come with a warning label, and because slow harm is harder to see than fast harm. A cave-in is obvious. A poison that nudges the brain over years is a quieter story. And once you start noticing consequences, you also start noticing the rules underneath. Simple, quiet rules that govern heat, air, and survival. Back in the mine, heat is not a dramatic blast. It is a slow pressure. It wraps around you as you walk deeper. The rock holds warmth the way a thick wall holds the day's sun. Even at night, underground, the temperature can stay stubborn. Your skin shines with sweat, not from effort alone, but from the environment refusing to let you cool down. Heat moves from warm to cool. That is the rule. It does it without malice and without exceptions. It is like a metronome, ticking in the background of everything you do. Your body makes heat constantly. Muscles, organs, metabolism, all of it produces warmth. Usually, you dump that heat into the air, and the air carries it away. Sweat helps too. When sweat evaporates, it takes heat with it. It is a clever trick, one of your best, but that trick needs cooperation. It needs airflow, so humid air does not cling to your skin like a wet cloth. It needs water, so you can keep sweating. It needs a place for the heat to go. A mind does not always provide those things. Air can be still, humidity can rise, water can be limited, and when sweat does not evaporate well, it does not cool you well. You stay hot, and heat makes everything feel heavier. Tools feel heavier, breathing feels heavier, time feels heavier. Outside, the night air can cool skin quickly. It pulls heat away like a quiet thief. Inside, the warmth lingers and does not let go. That is why miners often described mines as having their own weather. Underground, you do not negotiate with seasons. You negotiate with rock. The physics is not angry. It is consistent. It is comforting in a strange way, because once you know the rules, you can predict what comes next. Heat will flow. Air will mix or fail to mix. Gases will build up where ventilation is poor. Vapors will accumulate where they are produced. Dust will settle unless disturbed. And that is where the story circles back to Mercury again, because Mercury's danger depends on these simple rules. Warm it, and more enters the air. Trap the air, and it stays. Breathe the air, and your lungs do what they were built to do. Forget the dramatic myths of cursed mines. The curse is mostly bad ventilation and chemistry. But chemistry has its own quiet personality. It does not shove you. It persuades molecules to trade partners. And chemistry, in Mercury's case, explains why it behaves so strangely, why it beads up, why it clings to some surfaces, and why cleaning it is harder than you want it to be. Mercury beads up because its atoms hold onto each other with stubborn loyalty. The surface of that liquid metal behaves like a stretched skin. In human terms, it is as if the droplet is trying to stay dignified in a world of messy rock and dirty hands. Water loves to spread to wet surfaces, to crawl into tiny cracks. Mercury does the opposite. It pulls inward, staying round and tense. That behavior has a scientific name, surface tension, but you already understand it with your eyes. You watch a bead of mercury sit on stone like a cold pearl. You watch it roll when the ground tilts, and you realize it is not really touching much. It is making as little contact as possible because the internal pull is stronger than the desire to stick, and yet it does cling sometimes, which feels unfair. Mercury does not like to mix with water, but it can bond with certain metals. It can creep into tiny scratches in a tool. It can coat coins and rings and the seams of a workbench. It can form amalgams those intimate metal partnerships. And once it does, it can become harder to remove than you want to admit. You learn this the slow way. You wipe a spill, and it just splits into smaller beads. You chase them like you are trying to herd a flock of stubborn silver insects. Each time you touch one, it divides, because Mercury has a talent for becoming more surface area. More surface area means more evaporation. Congratulations! Cleaning the mess can make the mess more breathable. And for a long time, people tried the obvious solutions. Sweep it, wash it, push it into cracks, and forget it. All those methods feel satisfying because they look like progress. But Mercury does not care what looks satisfying. It cares what is possible, based on how atoms prefer to behave. Some materials hold on to certain atoms more tightly than others. That is the quiet logic underneath chemistry. It is not moral, it is not emotional, it is preference and probability. A sulfur atom, for example, has a strong attraction to mercury. Put sulfur in the right place, and mercury stops wandering and starts settling down. That is one reason certain cleanup methods use sulfur powders or sulfur-based compounds, because they turn mobile mercury into something more stable. But a miner does not have a modern spill kit. A miner has a rag, a bucket, and hope, so the mercury stays. It hides in the mine like a second occupation, one that works the night shift after you leave. You might think smell would warn you. You would like it to. A strong odor is the body's ancient alarm system, an inherited survival feature. Rotten food smells wrong. Smoke smells urgent. Certain plants smell like trouble. But mercury vapor has no reliable smell at the levels that still matter. It can be there without any sensory drama at all. Taste is not much better. The metallic taste miners describe is often a mix of dust, smoke, and plain exhaustion. Your mouth dries, your tongue picks up minerals, your gums and teeth catch residue. None of that tells you, with certainty, what is in the air. The world is full of dangerous things that do not announce themselves, so you understand the real insult of it. The hazard is not only poisonous, it is also quiet. It is a problem you have to learn to notice. And the learning, for humans, is always slower than the chemistry. When you stand in the mine, you are surrounded by reactions that you cannot see. Oxygen meeting carbon in a lantern flame. Water vapor condensing on colder stone. Minerals oxidizing in slow motion, changing color over decades. And somewhere among those ordinary processes, mercury atoms are occasionally escaping the liquid and joining the air. It feels almost gentle, almost peaceful, the kind of danger that does not chase you, it simply waits for you to keep showing up. And speaking of waiting, there is another slow cruelty here, one that has nothing to do with the metal itself. The mine has its own climate, and that climate obeys physics with a kind of bored efficiency. Down here, heat is not just warmth. Heat is labor that sticks to you. The deeper you go, the more the rock stops caring about the surface. Above ground, the day warms and the night cools. Underground, the temperature changes slowly, like an old mood that refuses to shift. The mine holds on to heat the way a thick blanket holds on to your body warmth after you get up. Part of that heat is simply the earth. Go deep enough and the planet gets warmer with you because the interior still carries leftover energy from formation and radioactive decay. It is not personal. It is just the planet's long afterglow. Part of that heat is you and the other bodies working beside you. Muscles burn fuel, and burning fuel makes warmth. Even thinking uses energy. Your brain is a demanding little organ, and it pays its rent in heat. Put enough humans in a confined space, and the air becomes slightly warmer, slightly wetter, slightly more difficult to breathe. Then add the lantern. Add the fires used for certain processes. Add the friction of tools against rock. Tiny inputs, always adding up. Heat moves from warm to cool, always trying to even things out. It wants the whole mind to be the same temperature, and it will take as long as it needs. If you are warmer than the air, you lose heat into it. If the air is warmer than you gain heat whether you agree or not. Your body tries to hold a narrow range of temperature. Too cold, and chemistry slows down. Too hot, and proteins start behaving badly, like workers going on strike. So you sweat, you open blood vessels near the skin, you try to dump heat into the environment. Sweating is clever, but it has conditions. Sweat cools you best when it evaporates. Evaporation is a quiet theft. It steals heat from your skin to turn liquid into vapor. But if the air is humid or still, evaporation slows. Sweat stays on you. It drips. It soaks fabric. It makes a salty film. It looks like cooling because it is wet, but the cooling only happens when it leaves. A mine often has damp air and poor flow. The same tunnels that trap mercury vapor can also trap humidity. So you sweat and you keep sweating, and you do not feel much relief. Your clothes get heavy. Your hands slip on tools. Salt stings, cuts you did not notice you had. And because sweating costs water, you become thirsty. Thirst is not polite. It starts as a suggestion, then becomes a demand. If water is scarce, or if breaks are rare, you keep working slightly dehydrated. That thickens your blood a bit. It makes your heart work harder. It makes you feel tired in a way that is not just muscle fatigue, but whole body drag. Outside, the night air is clean and cool. It carries heat away easily, and your skin can finally do what it was meant to do. You step out, and it feels like the planet has forgiven you. But even that contrast has a strange consequence. If you come out sweaty into cold air, you can chill fast. Evaporation suddenly works too well. Your body shifts from overheating to shivering. You are always negotiating, always adjusting, always trying to stay in the narrow middle where humans function. Physics is unfair, but it is fair in the same way to everyone. It does not target miners. It simply does not care that miners are tired, and the mine, being a cave carved into stubborn rock, does not offer the conveniences your skin expects. No breeze, no shade, no easy way for heat to escape. Heat pools in dead ends. It lingers in low passages. It sits on your shoulders like an invisible pack. Speaking of invisible packs, air itself can become heavy with things that do not belong there. Not just mercury vapor, not just dust. Mines can have pockets of gases that change how your body behaves in minutes. Carbon dioxide can collect in low areas because it is heavier than the nitrogen and oxygen mix you are used to. Methane can seep from coal seams, and it does not smell like danger unless other compounds ride along. Carbon monoxide can form from incomplete burning, binding to your blood with a grip that makes oxygen look weak. These are not the main characters tonight, but they haunt the edges of the story. They remind you of a simple fact. Your survival depends on air composition staying boring. You want air to be mostly nitrogen, a comfortable amount of oxygen, and a trace of other things that do not interfere. The moment the mix changes, your body starts improvising. Improvisation keeps you alive right up until it does not. That is why miners watched flames so closely. A flame is a crude sensor. If it burns weakly, oxygen is low. If it goes out, something is very wrong. If it flares strangely, there may be a gas that burns too well. The lantern is not just light, it is a warning system with a personality problem. In modern terms, you would use instruments, oxygen meters, gas detectors, ventilation models. But down here, in this older mine, you have a flame and a throat that starts to feel wrong when the air is wrong. And the worst part is that wrong air can feel like normal fatigue at first, slight dizziness, a headache that could be dehydration, a sense that your legs are heavy, a little confusion that you blame on poor sleep. Congratulations, your body's alarms sound like ordinary life. Even when you do everything right, the environment stacks small stresses on top of each other. Heat makes you breathe harder. Breathing harder pulls in more dust. Dust irritates your airways. Irritated airways make you cough. Coughing makes you tired. Tired hands spill things. Spilled mercury becomes vapor. Vapor enters lungs that are already working too hard. It is a system, not a conspiracy, just a set of processes that link together quietly like gears. And once you accept that, you start to see why humans needed rules, not moral rules, physical rules, practical rules, the kind you write down when you realize nature does not grade on effort. Fresh air matters, airflow matters, barriers matter, washing matters, time away from exposure matters. The problem is that you cannot invent those rules until you first admit the danger exists. That admission, historically, came slowly. Humans are excellent at noticing sudden disasters. We are much worse at noticing slow ones because slow ones look like aging or bad luck or personal weakness. So the story of Mercury is also the story of how people learned to measure the invisible. At first, it was just noticing patterns. The same men in the same workshops developed the same tremors. The same families living near certain operations had strange illnesses. The same towns downstream from certain waste piles had fish that tasted wrong or made people sick. No one had to understand the exact chemistry to suspect something was happening. They just had to stop pretending it was random. Early occupational medicine was often unglamorous. A doctor visiting a work site, a government clerk collecting reports, a scientist taking notes that no one wanted to fund. The work was not heroic. It was paperwork and persistence, which is the only kind of heroism the universe tends to allow. Eventually, measurement tools improved. You went from guessing to sampling, from sampling to quantifying, from quantifying to regulating. You learned to pull air through filters and analyze what was caught. You learned to capture vapor and see what it contained. You learned that tiny amounts can matter when exposure is constant. And as soon as you can measure something, you can argue about it. That is a human tradition as old as language. How much is too much? Who is responsible? What counts as proof? What counts as acceptable risk? Industry, understandably, preferred not to learn too quickly. Workers, understandably, did not have the luxury of refusing. Progress, as always, happened in the uncomfortable middle, dragged forward by evidence and tragedy. Ventilation was one of the first practical improvements because the solution to airborne problems is often boring. Move the air, dilute contaminants, remove them at the source if you can. Keep them from reaching lungs in the first place. In mines, ventilation can mean shafts that create natural drafts. It can mean fans that push and pull air through tunnels. It can mean carefully planned airflow so dead zones do not form where gases and vapors can accumulate. But ventilation costs money. It requires maintenance. It requires someone to care even when nothing dramatic is happening. That is the hardest part. Humans are excellent at reacting to explosions. We are less motivated by the absence of explosions. Masks arrive too in various forms. Early respirators were sometimes little more than cloth, which helps with larger dust, but not with many vapors. Better filters came later, materials designed to trap particles and absorb certain chemicals. Activated carbon, for example, is basically charcoal with an enormous internal surface area, full of tiny pores. It is like giving a gas molecule a maze to get lost in. Hand washing became a ritual of survival, not because miners were filthy in some moral sense, but because dust and residues travel with you. They travel into food, into homes, onto children, onto bedding. The mine does not always stay in the mine. Workplace rules began to form around these facts. Do not heat mercury indoors without control. Do not store it in open containers. Clean spills with methods that do not spread beads into smaller beads. Keep contaminated clothes separate. Monitor air. And the sad realism is that many of these rules were written in response to harm already done. Humans learn the shape of danger by bumping into it. There is a strange comfort, though, in the record keeping. A written report does not heal a tremor. A measurement does not undo a damaged lung. But it makes the problem harder to deny. It turns a ghost into a quantity. It turns a suspicion into a graph. And once you have a graph, you can start building barriers between bodies and hazards. Records are one of the reasons you, in your bed, are not accidentally playing with mercury in a classroom. Records are why thermometers changed, why regulations exist, why certain pigments are handled differently, why the phrase, "mad as a hatter," now reads like a warning, not a joke. But even with modern knowledge, mercury does not stop being mercury. It simply finds new pathways, because the moment mercury escapes a mine or a workshop or a waste pile, it does not vanish. It travels. You can picture it leaving in slow motion, a little vapor rising from a warm surface, a little dust carrying mercury compounds into the wind, a little wastewater moving through ditches into streams. None of it looks dramatic. It looks like ordinary pollution, which is just a fancy word for human leftovers entering natural cycles. In the air, mercury can drift far. It can ride currents above forests and oceans. It can exist as elemental vapor for a while, long enough to cross regions, even continents. Eventually, it can oxidize, reacting with other chemicals in the atmosphere, turning into forms that settle more easily. Then it falls, sometimes with rain, sometimes with dry particles. It settles onto soil and water like invisible ash. In soil, it can bind to organic matter, the dark, rich stuff made from decaying life. Wetlands are especially interesting, in the way a swamp is always interesting if you like quiet horror. Wetlands have low oxygen zones in their mud. They have microbes that thrive in chemical gradients, using sulfur and iron and other compounds in their metabolism. Some of those microbes can take inorganic mercury and convert it into methylmercury. That word sounds tidy. The reality is not. Methylmercury is mercury with a carbon-containing group attached. That small change makes it behave differently in living systems. It becomes more likely to enter organisms and stay there. It binds strongly to proteins. It crosses biological barriers more easily. In plain human terms, it is mercury wearing a disguise that gets it invited inside. Once methylmercury exists in water, it joins the food web. Tiny organisms absorb it. Small fish eat those organisms. Bigger fish eat the small fish. At each step, the mercury does not dilute the way you wish it would. It concentrates. This is called bioaccumulation and biomagnification. But you do not need the vocabulary to feel the effect. Imagine you are a small fish in a quiet lake. You eat constantly because that is what being a fish means. Each meal contains a tiny trace of mercury, not enough to kill you today, not enough to taste, not enough to notice, but you do not get to stop eating. You keep adding tiny traces. Your body cannot easily get rid of it. It settles into tissue, it binds, it stays. Then a bigger fish eats you. It does not receive just the mercury from your last meal. It receives the mercury you collected over your whole life. It eats many fish like you. It collects many lifetimes worth of traces. By the time you reach a top predator fish, the mercury concentration can be high enough to matter to the predator's nervous system. And if humans catch and eat that fish regularly, the mercury climbs again into a creature that lives long and remembers things and tells stories. Nature does not judge this. Nature is not punishing anyone. This is just chemistry moving through ecology, step by step, patiently. It is also one reason modern health advice sometimes focuses on which fish you eat and how often. Not because fish are evil, because the ocean and the atmosphere have been receiving our leftovers for a long time. And mercury is not only a legacy of old mines, it also comes from burning coal, because coal contains trace mercury from ancient plant material in geology. When you burn vast amounts of coal, you release that mercury into the air. It becomes part of the global cycle, a quiet tax paid by everyone who breathes downwind. So mercury becomes a traveler, from rock to air, from air to water, from water to microbes, from microbes to fish, from fish to people. A long chain of small steps, each one ordinary and together consequential. If you want the most unsettling part, it is how slow and wide the journey is. You can mine mercury in one region, and the mercury can end up affecting another. You can release it in one decade, and it can persist into the next. The planet is very good at mixing. Winds, rivers, and currents are nature's delivery service. They do not accept refunds. You can watch this in your imagination like a map lit dimly at night, a plume rising from a smelter, a thin haze dispersing, particles settling onto a distant mountain lake, a microbial conversion. in the mud, a trout growing fat in cold water, a person cooking that trout in a warm kitchen, never meeting the miner who started the chain. And yet, the miner is still there in the story because humans are the ones who cut the first link. Back in town, the miner's world is small. It is a room with a table. It is bread and stew. It is hands that ache when they finally rest. It is a laugh that comes easily with others who understand the same fatigue. Hardship normalizes itself when it is shared. If everyone's clothes smell faintly of smoke and stone, the smell becomes home. If everyone coughs in the morning, coughing becomes a kind of greeting. Humans adapt socially as much as physically. It is one of our talents and also one of our traps. You can see that trap in the way danger becomes routine. A man with shaky hands is called nervous. A woman with headaches is called delicate. A child who struggles in school is called lazy. The environment writes on bodies, and society interprets the handwriting as personality. That is why understanding matters. Not as a panic, but as shelter. When you can name a hazard, it becomes less mystical. It becomes a thing with causes and pathways and controls. The unknown is always louder than the known. Mercury, once understood, becomes a managed risk rather than a curse. You do not make it harmless, but you can keep it contained. You can design processes that capture vapor. You can use alternatives where possible. You can treat waste so it does not wander into rivers. You can monitor workers and environments. You can build rules that are enforced, not merely suggested. And the irony is that none of this requires humans to be morally better. It requires us to be administratively stubborn, to keep checking even when nothing dramatic is happening, to maintain fans and filters, to keep writing down measurements, to admit that prevention is more boring than disaster, and therefore more important. The miner, of course, does not get to live in that future yet. He lives in the era of partial knowledge. He knows the obvious dangers. He suspects the air is wrong. He feels the dust in his chest. He tastes metal and calls it part of the job. He goes to bed tired because there is no other way to go to bed after a shift underground. Sleep comes heavy, not always peaceful, but heavy. And as you sit with that image, you start to notice something else about human work. Humans keep putting their bodies in places those bodies were never designed for. Deep underground, high in the sky, under the ocean, inside factories full of vapors and dusts. We do it for money, for necessity, for ambition, for the simple fact that someone has to do it. Sometimes we do it because the substance seems ordinary. A metal, a gas, a mineral. Nothing mythical. Just matter. And yet matter has a way of reshaping lives when it is concentrated in the wrong place. Mercury is one chapter in that library of quiet elements. There are others. Lead that tastes sweet and steals cognition. Arsenic that hides in groundwater. Radon that seeps through basements. A radioactive sigh from the earth. Each one has its own personality, its own path through bodies and history. But for now, you are still lingering in Mercury's shadow, following its roots and its rules, because the more you trace them, the more the mind stops being the romantic hole in the ground and becomes what it always was, a place where physics and chemistry meet human lungs and human need, where heat moves, where air stagnates, where dust drifts, where a metal can become a vapor, and where the body keeps trying to clean up the mess with the tools it has. And speaking of tools, once people finally accepted mercury as a problem, they had to build a new kind of tool. Not a pickaxe, not a shovel, a tool that could detect what your senses could not, quietly, reliably, night after night, because the most dangerous part of an invisible traveler is that it can be everywhere and still feel like nothing at all. So you give yourself a new sense, not sight, not smell, not taste, but measurement. You step out of the mine and into a room that feels almost too clean to trust. The air is cooler here, but it is not fresh in a romantic way. It is fresh in a controlled way, like water from a tap that has been filtered until it forgets where it came from. On a wooden table sits a glass vessel with narrow tubes, stopcocks, and a faint fog of residue you only notice when light hits it sideways. Someone in an apron is turning knobs with the calm confidence of a person who believes in numbers. You are not watching magic. You are watching the slow invention of proof. The first problem is simple and cruel. Mercury vapor is real, but your nose is not an instrument. So you need something that behaves predictably, even when you are tired, even when you are biased, even when you desperately want the air to be safe, because your paycheck depends on it. You start with air itself. You take a known volume and you pull it through something that will catch what you cannot. In the earliest days, that something might be a chemical solution in a bottle, a trap. The air bubbles through, and whatever reacts. A color shift, a precipitate forming, a new compound settling out like quiet snow. It is a slow way of learning, and it feels almost insulting. You spend hours collecting what your lungs would have collected in seconds. But that is the point. You are trying to separate panic from reality and reality from wishful thinking. Later, you get more elegant tools. You learn to use sorbent tubes packed with materials that adsorb chemicals onto huge internal surfaces. Adsorb, not absorb. One letter difference, a whole personality change. Absorb is a sponge taking water into its body. Absorb is dust sticking to tape. Mercury in air likes to stick if you offer the right surface. Then you heat the tube or wash it, and you release what was captured into a detector that has no imagination. A detector does not care if the mine owner is charismatic. It does not care if the worker is desperate. It produces a line on paper or a signal on a screen, and the signal corresponds to a quantity. And once you can quantify mercury, you can do the most human thing possible. You can negotiate with it, you can set exposure limits, you can debate what level is acceptable for an adult, for a pregnant worker, for a child living near a river. You can do what humans do best when faced with discomfort. Turn it into bureaucracy. This is not an insult. Bureaucracy is how you make safety boring. It is how you turn horror into routine maintenance. It is the way you build a fence around an invisible cliff. You find out, slowly, that mercury is not one hazard, but a family of hazards. Elemental mercury vapor behaves one way. Certain inorganic salts behave another. Methyl mercury behaves like the worst kind of guest. Polite, quiet, hard to remove, and somehow always sitting too close to the nervous system. So different workplaces need different rules. A mine needs ventilation and dust control. A workshop heating amalgam needs local exhaust and capture. A laboratory needs containment, spill protocols, and the basic humility to stop doing party tricks with liquid metal. Even the cleanup becomes its own science because mercury does not cooperate with simple wiping. It beads and hides. It breaks into smaller beads that roll into cracks. So you invent ways to corral it. You use suction devices and sticky tapes. You use sulfur powders that bind mercury into less volatile forms, pushing the chemistry in a direction you prefer. It is all very civilized in a late-night sort of way. Humans, faced with a problem they cannot punch, eventually build a device. But the mine is older than that device. The town is older than that policy. And down there, under stone, you are still in the era where the best detector is a symptom. Which is why the story keeps returning to bodies. You can measure air all you want, but the body is where the consequences show up first. It is where invisible becomes undeniable. And this is where the path gets uncomfortable, because mercury does not just irritate, it interferes. You can picture your nervous system as a long chain of messages passed along by electrical changes and chemical signals. Neurons are cells that specialize in being dramatic in the quietest possible way. They maintain differences in charge across membranes like tiny batteries. They release neurotransmitters at synapses, those microscopic gaps where one cell whispers to the next. Mercury can bind to sulfur-containing parts of proteins. It likes sulfur. It clings to it with a kind of chemical greed. Many proteins rely on sulfur-containing groups for their shape and function, like hinges in a folding machine. So mercury is not just an intruder, it is an intruder that grabs the hinges. When proteins change shape, they stop doing their jobs properly. Ion channels get weird. Enzymes slow down. The delicate choreography that keeps neurons firing in patterns becomes less coordinated. You do not need to imagine a single dramatic failure. It is more like a city with traffic lights slightly out of sync. People still get home, but they honk more. They collide more. They arrive later, more exhausted, and no one quite knows why everything feels harder. That is why the early signs can be mood and sleep, irritability, anxiety, a mind that feels less steady, then tremor, fine motor issues. The handwriting that used to be neat becomes slightly jagged. The spoon shakes in the hand. Not enough for a tragedy, just enough for embarrassment. Congratulations, the poison is subtle enough to feel like personality. And while the nervous system is struggling, the kidneys and liver are still doing their jobs. They are trying to package and excrete, but mercury can accumulate in tissues, especially in forms that bind tightly to proteins. It is not a simple rinse out. This is where you learn a bleak lesson about biology. Your body is excellent at handling problems it evolved to handle. It is less excellent at handling 19th century industrial chemistry. Evolution did not prepare you for vaporized heavy metals drifting into the alveoli 8 hours a day because your ancestors had the decency to die from simpler things. Still, humans adapted in the only way we reliably do. We changed the environment. Ventilation became engineered. Fans got stronger. Airflow got planned instead of hoped for. Minds learned to move air like a circulatory system. Fresh air in, stale air out, like breathing for the entire underground world. And that brings you to another quiet truth. A mine is not a hole. It is a lung. If air moves poorly, the mine suffocates its workers. If air moves well, the mine can be inhabited longer, not comfortably, but survivably. That is why airflow is not just comfort, it is life. You feel it when you stand near a ventilation shaft. The air has a direction. It presses against your skin. It carries a smell from somewhere else, a different tunnel, a different depth. It is the mine exhaling, and in that moving air, mercury vapor is less likely to build up. Dust is less likely to hang. Carbon monoxide is less likely to linger. Less likely does not mean impossible. It means your odds have been adjusted slightly toward tomorrow. But even with airflow, the mine cannot fix the fact that you are drilling and blasting and breaking rock, which means the dust never really stops. Dust is the slowest disaster because it is not a single event. It is exposure as a lifestyle. It is a background that becomes a foreground. Decades later, you can picture a dust particle landing in your airway. Your body reacts with irritation, a mild inflammation. Mucus production increases. Cilia, tiny hair-like structures, beat upward, trying to move debris out like a conveyor belt you never see. For many particles, this works. You cough, you clear your throat, you swallow mucus. It is unpleasant, but it is maintenance. But for the finest particles, the ones small enough to reach the deepest regions, the body's cleanup becomes harder. Macrophages engulf them. If the particles are biologically inert and removable, the macrophages can carry them away to be cleared. If the particles are sharp, like silica, they can damage the macrophages. The macrophages die and release inflammatory signals. More macrophages arrive. The immune system gets stuck in a loop, like an argument no one can leave. Over time, this chronic inflammation can lead to scarring, fibrosis. Scar tissue is the body's way of patching damage. It is strong. It is not flexible. Lungs need flexibility. They need to expand and recoil like soft bellows. So as scarring increases, breathing becomes less efficient. Not suddenly, slowly. Like wearing a tighter shirt every year until you forget what loose felt like. The cruel elegance of it is that the lung has a lot of reserve. You can lose function and still walk and work. So the damage can build while life continues, which means the workplace can keep pretending nothing is happening because the workers keep showing up. And that, again, is why measurement matters. Not just measuring air, but measuring bodies, listening to lungs, recording symptoms, tracking patterns. A miner does not want to be a data point. A miner wants to be paid, to eat, to sleep. But history turns you into a data point anyway, because someone later needs to prove that the cough was not just a cough. So the records grow. They are boring and essential. They are names, dates, job titles, exposures. They are the opposite of poetry. They are what keeps future workers from repeating the same mistake, at least sometimes. And while all this is happening, Mercury keeps moving through the world outside the mine. Not quickly, not dramatically, just persistently. In the atmosphere, Mercury can exist long enough to travel across oceans. That is the part that feels almost supernatural, if you let it. A metal, once locked in rock, now drifting like a ghost in the sky. But it is not supernatural. It is physics and chemistry on an indifferent schedule. Mercury vapor can be oxidized into forms that deposit more readily. Once it falls into water, it can be transformed by microbes into methylmercury. Especially in wetlands and sediments, where oxygen is low and microbial metabolism has room to get creative. That microbial creativity is not malicious. Microbes are not plotting. They are just using available chemistry to survive. If mercury is present, it becomes part of their environment, and they alter it as they alter everything else. Methyl mercury then moves into the food web and accumulates, and because it binds strongly to proteins, it tends to stay in muscle tissue. That is why fish muscle can contain it, and why predators end up with more. This is one of the rare times where your nightly dinner can connect to a mining practice from far away and long ago. The chain is long enough that no one feels responsible, which is the most comfortable arrangement humans have ever invented. Still, knowledge creeps in. Public health agencies begin issuing advisories, not because fish are dangerous in some dramatic sense, but because risk is uneven. Some waters are more contaminated. Some species are higher on the food chain. Some people are more vulnerable, especially developing nervous systems. So you get these calm, bureaucratic sentences that carry the weight of a whole planetary cycle. Eat smaller fish more often. Limit large predatory fish. Pay attention to local advisories. It is not fear, it is management. And in that same spirit, industries change. Mercury thermometers become less common, replaced by alcohol thermometers, digital sensors, thermistors. Not because digital is morally superior, but because fewer liquid mercury spills is a practical form of kindness. Old industrial processes shift. Chloralkali plants, which once used mercury cells in some methods of producing chlorine and sodium hydroxide, begin transitioning away. Regulations tighten. Cleanup efforts begin in contaminated sites. This is what progress often looks like. Not a bright leap forward, but a long list of substitutions, retrofits, and quiet acknowledgments that yesterday's cleverness had a price. But the mine remains in your mind, because the mine is where the human story is most intimate. You can still feel the grit in the mouth, the weight of heat, the way lantern light makes the air look thick, the way your body knows, without words, that something in the environment is asking for payment. And now, with the tool of measurement in mind, you can look back at the mine and see it differently. You can see the parts that mattered. Where did the air flow? Where did it stagnate? Where was mercury stored? Where was it heated? Where did dust collect? Where did water pool? Turning the floor into paste that dried into powder again. You can see how a miner's habits became exposure pathways. Eating with dusty hands, smoking a pipe underground, pulling air deep into lungs, wearing the same clothes home, shaking them out near a door where children played. These are not moral failures. They are ordinary behaviors in a world that had not yet admitted what it was doing. And now you can pivot into a different kind of truth, the one that always follows measurement. When you can measure something, you can pretend you control it. Sometimes you do. Sometimes you just understand the shape of the loss. Because even with rules, mercury still escapes. Even with filters, dust still exists. Even with ventilation, people still get tired and make mistakes. The universe is not waiting for your compliance checklist. So you end up with a pragmatic philosophy that feels almost soothing in its bluntness. You reduce risk. You do not erase it. You build layers. You assume failure will happen. You design so failure is survivable. That is the engineering mindset, and it is the closest thing humans have to a spell. You put the hazard in a container. Then you put the container in a cabinet. Then you ventilate the cabinet. Then you monitor the air. Then you train the worker. Then you write the procedure. Then you audit the procedure. Then you revise it after the next incident, because there is always a next incident. Cozy, in a way, a little exhausting, very human. And while all that systems thinking hums along, you return to the simplest detail of all, the miner's hand, holding the lantern. The flame consumes oxygen and makes heat and byproducts. It is a tiny chemical factory you carry into the dark. The flame is bright and warm and, if you stare at it long enough, hypnotic. It is also a reminder that chemistry is always happening, even in your bed, even in your room, even in a quiet house at night. Molecules are trading partners. Oxygen is reacting in your mitochondria. Glucose is being broken down. Your cells are producing carbon dioxide and water. Heat is being released. You are, in a literal sense, burning slowly. The mind is just a place where the reactions become less forgiving. And speaking of chemistry being less forgiving, there is a particular unfairness in the way mercury interacts with some materials and not others. It does not wet glass easily, which is why it can sit in a bead. It can wet certain metals more readily, which is why it can creep and cling and form amalgams. That preference comes from the way electrons are shared, the way metallic bonds and surface energies work out. In human terms, mercury is selective about what it wants to touch. If you spill it on a rough surface, it breaks apart and hides. If you spill it on a smooth surface, it rolls like a living thing. If you spill it into a crack, it becomes a long-term resident. And that is why mercury spills in old buildings can become stubborn problems. It is not just the moment of the spill, but the decades of slow vapor release afterward, especially if the environment warms up. Warmth matters. That simple rule again. If you heat mercury, it evaporates faster. If you heat a contaminated surface, it releases more. If you trap air, vapor builds. If you move air, vapor spreads or dilutes. So the practical advice becomes simple and oddly unromantic. Do not vacuum mercury with a normal vacuum cleaner because it will break droplets into tiny particles and heat them with the motor. Congratulations, you have turned a spill into an aerosol generator. Instead, you use specialized methods. You collect beads carefully. You use amalgamation agents like sulfur. You contain and dispose properly. You ventilate. You measure. Boring. Effective. The two words humans keep learning to respect. And now, because your mind likes associative bridges, you notice something. Mercury is dangerous, partly because it is invisible in air. Dust is dangerous, partly because it is too visible to take seriously. Heat is dangerous, partly because it feels like discomfort, until it becomes illness. These are three versions of the same lesson. The body is bad at forecasting. Your nervous system is excellent at responding to immediate threats. Sharp pain, sudden cold, a loud noise, but slow threats, low-level exposure, chronic irritation, gradual dehydration do not trigger the same alarm bells. They whisper instead of shout. So survival in industrial environments becomes a matter of externalizing your alarms. You build detectors, you build rules that do not rely on how you feel in the moment. You create a world where safety does not depend on intuition, and that is where science, as history, becomes almost tender in its own cynical way. Because every sensor, every regulation, every ventilation standard is the fossil record of someone's suffering. Not heroic suffering, just the common kind. The kind that happened in a workshop on a Tuesday. The kind that did not make newspapers until it happened to enough people. So the air tool sits on the table and it hums quietly in your imagination, and you understand it is not just a device. It is a memory. But the mine is still producing. The world is still using Mercury for certain things, even today, in controlled contexts, and the environment is still cycling it. So you follow Mercury farther because it is not done being a traveler. You imagine it settling into a lake, not a dramatic poisoned lake, just an ordinary body of water with reeds at the edges and dark mud at the bottom. You can hear insects. You can smell wet plants. The surface reflects the sky, calm and indifferent. Down in the sediment, microbial life is busy. It is always busy. Microbes do not sleep the way you do. They are chemical machines, turning whatever they can into energy. They use oxygen when it is available, and when it is not, they switch to other strategies. Some use sulfate, some use other compounds. In these low oxygen zones, mercury can be transformed into methylmercury. This is not a guarantee, but it is a known pathway, especially in certain conditions. Then the methylmercury enters tiny organisms, plankton, invertebrates, the base of the food web. And because methylmercury binds strongly to proteins, it stays. As you move up the food chain, you see why biomagnification happens. Each predator eats many prey. Each prey carries its own small burden. The predator accumulates the burdens of many lives. It is like inheriting debt you never agreed to. And in a top predator fish, the burden can become large enough to matter, not just as a statistic, but as a biological effect. In fish, methylmercury can affect behavior and reproduction. It can alter swimming patterns, predator avoidance, and developmental processes. It can reduce survival in subtle ways that ripple through ecosystems, which is the other uncomfortable truth. Mercury does not only affect humans, it affects whatever shares the water and the air. But again, nature does not judge. The fish are not morally injured. They are just living in chemistry that has changed. And then humans catch fish, because humans are also predators with grocery lists. We are part of the same chain, just with better cooking methods and worse self-control. So public health becomes a balancing act. Fish are nutritious. Fish contain omega-3 fatty acids. Fish are a food source for many communities. Fish are also sometimes a pathway for methylmercury exposure. So recommendations become nuanced, which is a polite word for annoying. Eat some fish, but not too much of certain kinds. Pay attention to local contamination. Be especially careful during pregnancy and early childhood, because developing nervous systems are more sensitive to disruption. This is not meant to be frightening. It is meant to be realistic. The world is full of trade-offs, and humans keep trying to make those trade-offs with incomplete information. Mercury is just one of the more poetic examples, because it starts as a liquid metal you can roll in your palm and ends as a molecule in a fish muscle, and then as a warning sentence in a pamphlet. A long journey with many quiet steps. And after all that travel, your mind returns inevitably to the mine again, because that is where the human scale is easiest to feel. You picture the miner at home, boots by the door, clothes hung to dry, stiff with dust, a bowl of water darkening as he washes his hands. The skin around his nails is cracked. His knuckles are swollen. He rubs his fingers as if trying to get sensation back. He eats something plain. Bread, stew, maybe salted meat. Calories are the currency of survival, and work burns through them. The body, again, is not a hero. It is a machine that needs fuel. And then sleep. Sleep in a mining town is not sacred. It is practical. It is a reset button the body presses because it has to. The miner lies down, and the muscles soften, and the lungs keep moving anyway, pulling air into tissue that has been irritated all day. You can feel the strange intimacy of it. The body does not stop working when you stop working. It keeps cleaning. It keeps repairing. It keeps filtering. This is where you can see endurance as a kind of quiet bravery, even if no one calls it that. And while this miner sleeps, somewhere else, a scientist stays awake, writing down observations, trying to connect symptoms to exposures. Two humans in different rooms, both working in their own way, both paying for knowledge with time. That is how safety slowly arrives, not as a gift, but as a gradual accumulation of notes. And speaking of notes, there is one more subtle detail that shows up in the records over and over. Exposure is not just concentration. Exposure is also time. A high concentration for a short time can be dangerous. A low concentration for a long time can also be dangerous. The dose accumulates. The body's ability to clear or repair becomes the limiting factor. This is why chronic low-level exposure can be so deceptive. It does not trigger immediate collapse. It just shifts the baseline. So when modern occupational health talks about time-weighted averages, it is trying to capture that reality, not just how much is in the air, but how long you are breathing it. And when modern public health talks about limiting fish meals, it is doing the same thing. Not just the concentration in a fish, but your eating pattern over weeks and months. Time is a chemical ingredient, which means the mind, with its long shifts and repeated days, is a perfect machine for turning small hazards into big outcomes. And that brings you gently back to dust again, because dust is the hazard of time made visible. Dust exposure does not always kill. Often it just steals capacity. It makes the future narrower. A person who could once climb stairs without thinking starts to pause. A person who could laugh without coughing starts to choose silence more often. A person who could sleep through the night starts waking with a dry throat and a heaviness in the chest. Not dramatic, just altered. And if Mercury is involved too, you add neurological changes to respiratory ones, and the human becomes a little less steady in multiple ways. The hands shake, the breath shortens, the mood shifts. The mind does not need to collapse to take something from you. It can take it one small trait at a time. Now, if you are the kind of person who wants the mechanism, you can look closer at the lungs, because the lungs are not just bags. They are architecture. The branching structure is like an upside-down tree. Large trunks becoming smaller branches, becoming tiny twigs ending in clusters of alveoli, like grapes. This design maximizes surface area for gas exchange. Surface area is the whole point. The lungs give you an absurd amount of interface with the outside world. It is one of the most intimate relationships you have. Every breath brings the environment into contact with your blood, separated by a thin barrier. So, any airborne hazard that can reach the alveoli has access to that interface. That is why fine dust matters. That is why certain gases are lethal at low concentrations. Your lungs, designed to keep you alive, are also your main vulnerability. Congratulations. Your survival system is also your exposure system. And the body's defenses, while impressive, are not perfect filters. Mucus traps some particles, cilia move them, macrophages eat them, lymphatic systems transport them. But when the load is constant, the defenses become stressed. In silica exposure, for example, the immune response can produce scarring. In coal dust exposure, the accumulation can darken lung tissue and contribute to chronic disease. In smoke exposure, you add chemical irritants that inflame airways. And in mercury vapor exposure, the hazard crosses into blood, affecting multiple organs. The lungs become the doorway, but the rest of the body becomes the house the intruder wanders through. So, over time, humans begin to treat mines as engineered environments, not just tunnels. You see the birth of industrial hygiene, the discipline of anticipating and controlling workplace hazards. It sounds boring, and it is. It is also one of the most compassionate forms of science because it acknowledges that workers are not disposable. Industrial hygiene looks at the whole chain: source, pathway, receiver. Where is the hazard generated? How does it travel? Who is exposed? You can remove the hazard, substitute it, isolate it, ventilate it, administratively control it, or protect the person. Those are the basic strategies, like a checklist you can apply to any workplace. Remove mercury, substitute safer materials, isolate processes, ventilate, limit time, use protective equipment, monitor. It is not glamorous. It is the science of making things less tragic. And yet, the world never fully stops using mercury, because mercury has properties that are genuinely useful. It conducts electricity. It forms stable contacts in switches. It expands predictably with temperature. It has unique behavior in certain lamps and instruments. So in some areas, you manage rather than ban. You keep it in sealed systems. You capture emissions. You train handlers. You treat waste. The cost is constant vigilance, which is a very human burden. The universe does not require vigilance. The universe will happily let you forget. So you build reminders into the environment. Labels, procedures, alarms, secondary containment trays, fume hoods, spill kits, all the little physical rituals that keep a substance from becoming a story you regret. And because humans are humans, sometimes the reminders fail. Someone leaves a container open. Someone spills. Someone cleans it wrong. Someone dismisses symptoms. Someone says, "It is probably fine." Probably fine is a dangerous phrase. It is the lullaby of industrial accidents. But you are not here for panic. You are here for the slow understanding of why it sucked to be a mercury miner and how that suffering etched itself into the way we now treat invisible hazards. So, you return, again, to the mine's air. Air is not nothing. Air is a mixture with properties. It has density. It has humidity. It carries particles and vapors. It flows according to pressure differences and temperature gradients. In a mine, Airflow can be driven by natural convection, warm air rising, cool air sinking. It can be driven by wind at the surface. It can be driven by fans. It can be blocked by collapsed passages. It can be complicated by multiple shafts and levels. Engineers learn to model airflow because the mine is a three-dimensional maze with its own weather. They learned that dead zones are dangerous. Places where air does not exchange become pockets where gases accumulate. Carbon dioxide can pool low. Methane can accumulate high, depending on conditions. Mercury vapor can build near sources. Dust can hang where there is no flow to carry it away. So ventilation planning becomes a kind of underground cartography. You map not just tunnels, but currents. And then you realize something quietly profound. The mine is like a living organism. It has intake and exhaust. It has circulation. It has stagnant regions like clogged vessels. It has feverish hotspots. It has toxins. You have built a second body inside the earth, and you are asking your first body to live inside it. No wonder it feels unnatural. And speaking of unnatural, you remember the hatters again. Not because hats matter, but because the phrase survived longer than the worker's health. The hat-making process used mercury nitrate to help mat fur. When fur was treated, dried, and worked, mercury compounds could become airborne as dust or vapor during heating. The workers inhaled and absorbed it. Over time, neurological symptoms appeared: tremor, irritability, shyness, and social withdrawal, memory problems. This cluster of symptoms was sometimes called erethism, a term that sounds delicate but describes a very real change in personality and cognition. It is a reminder that toxins can alter not just the body, but the self, or at least the behavior you recognize as self. Which is why mercury exposure history is full of social consequences as well as medical ones. People were labeled unstable, lazy, drunk, mentally ill. Sometimes they were. Sometimes they were poisoned. The workplace rode on their nervous systems, and society read it as character. Records helped change that interpretation. Slowly, medical case reports, workplace studies, animal experiments, chemical analyses. Not perfect science at first, often messy, sometimes wrong, but trending toward truth. And in that trend, you see how science actually works when it is not a polished textbook diagram. It is observation, argument, revision, and eventually policy. It is also often too late for the first generation exposed. That is the bitter joke of progress. The pioneers are not always brave explorers. Sometimes they are just workers who got there first. Congratulations, you were early. Now, you might wonder how scientists actually detect mercury in samples, because the phrase detect can sound like a vague superpower. One classic approach involves turning mercury into a form that can be measured by how it interacts with light. Mercury atoms absorb certain wavelengths. If you vaporize mercury in a controlled chamber and shine light through, you can measure how much is absorbed. The more mercury, the more absorption. This is the logic behind techniques like atomic absorption spectroscopy, which sounds like a spell but is really just a lamp, a sample, and a detector arranged with care. Other techniques involve separating chemicals in a sample and identifying them by mass and charge, like a sorting machine for molecules. Gas chromatography, paired with mass spectrometry, is one of those heavy-hitting methods, and it can detect tiny amounts. But even without the details, the point is that modern instruments can see what your body cannot. They can detect levels far below what would cause immediate symptoms. That is both comforting and unsettling, because it means you can discover contamination you would never have guessed was there. You can find mercury in remote lakes, in Arctic ecosystems, in places far from any mine. Not because mercury originates there, but because the atmosphere is a conveyor belt. And the Arctic, cold and quiet, becomes a kind of sink for global pollutants, with long-range transport bringing contaminants to places that feel untouched. Nature has no such thing as untouched, only less visited. This is where the cosmic horror vibe gets cozy. The planet is one connected system. The air and water mix. The chemicals travel. Your home is not sealed from the world. It is just buffered by distance and infrastructure. And infrastructure is what you pay for when you pay for modern life. Water treatment, emission controls, workplace regulations, waste disposal, boring systems that keep you from tasting metal in your mouth every day. But you are still thinking about the miner, because the miner did not have those buffers. In the miner's era, the boundary between work and life was thin. The mine dust came home. The mercury residues came home. The water might have been drawn from a source that was already receiving runoff. You can picture a creek near a processing site with a faint sheen in certain light, not always visible, not always constant, just present enough to matter over time. People washed clothes there. Animals drank there. Children played there. This is not negligence. This is what happens when the environment becomes a dumping ground without anyone admitting it is happening. And then, years later, someone notices a pattern. Illness, strange symptoms, poor development, fish die-offs, a smell that comes and goes. The investigative work begins. Sampling, testing, mapping contamination, tracing sources. The story repeats across industries, not just mercury. But mercury is particularly good at traveling and transforming, which makes it a perfect case study in the limits of human boundaries. A fence around a mine does not fence the atmosphere, so you end up with agreements and treaties aimed at reducing mercury emissions globally. The logic is simple. If the pollutant is global, the solution has to be coordinated. This is where cynicism feels appropriate. Humans can barely agree on what to eat for dinner, and now they are trying to coordinate atmospheric chemistry policies. It is almost sweet, and yet some progress happens. Emissions decrease in some regions. Processes improve. Monitoring increases. The world does not get clean. It gets slightly less careless. And that brings you, gently, toward the next part of the journey. Because mercury is a chapter, but the deeper theme is work, risk, and the way humans normalize environments that are objectively hostile. The mine is a perfect example because it is literally underground, a place the human body did not evolve to inhabit for long periods. The air is different. The heat is different. The dust is constant. The light is artificial. Time feels strange and still. Humans made it normal. They made jokes. They formed routines. They built towns with bakeries and bars and families. They created a culture around descent into the earth. That normalization is both beautiful and grim. It is the way humans survive psychologically. You cannot live in constant terror, so you turn danger into background. You name the tunnel. You nickname the foreman. You complain about the food. You laugh when someone's lamp goes out and they curse. Your nervous system learns what to ignore, but ignoring is not the same as being safe. So when modern readers look back and think, why did they do that? The answer is usually not greed. It is continuity. It is the fact that the job existed and the pay existed and alternatives did not. And in those conditions, risk becomes a currency. You spend your health gradually to buy rent and bread and the brief comfort of belonging somewhere. It is not romantic. It is honest. And now, because you have been following Mercury through air and water and bodies, you can feel the shape of the larger lesson without it being shouted at you. Human life is often built on materials we do not fully understand at first. We learn by using. We discover consequences by living them. We write the rules afterward. The mine is not a villain. The mine is a classroom with tuition paid in lungs. So you let the miner's world settle in your mind for a while longer. The clink of tools, the hiss of a lamp, the low murmur of voices, the soft scrape of boots over grit. And then you notice something small, something domestic. The miner's hands, when he finally rests, are not just dirty, they are stained. The dust has found the cracks in skin. It has embedded into the lines of fingerprints. Soap helps, but only partly. The mine has marked him. That marking is not just cosmetic. It is a reminder that skin is a barrier, but not an absolute one. Certain compounds can be absorbed through skin, especially with prolonged contact. Mercury, in its elemental form, is not absorbed well through intact skin. But some mercury compounds can be, and the skin can be broken. Cuts happen, abrasions happen. The mine makes sure of it. So protective gloves matter. Washing matters. Not because cleanliness is virtue, but because the boundary between outside and inside is thinner than you want to admit. And when the boundary fails, the body tries to compensate again. Inflammation, repair, scar formation, detox pathways, always balancing. This balancing act is the quiet heartbeat of the story, and it connects to something you can feel right now, even without thinking about it. You are a creature that must constantly maintain internal conditions against an external world that does not care. Temperature, pH, salts, oxygen levels, water levels, all of it must be held within ranges. The mind pushes on those ranges, mercury pushes, dust pushes, heat pushes, and yet people kept going underground. Because humans are not built to avoid discomfort. Humans are built to endure it, especially when it is normalized. So by the time regulations and instruments arrive, they arrive into a culture that already has its own traditions. Some workers resist masks because they feel suffocating or because they signal weakness. Some managers resist ventilation upgrades because they cost money. Some towns resist acknowledging contamination because it threatens livelihoods. This is the messy part of science as history. Evidence does not automatically change behavior. It has to fight culture, economics, and pride. And sometimes it wins, slowly. Sometimes it loses for a while. But in the long view, the arc bends toward knowledge. Mostly because reality keeps being consistent. People can argue about it, but lungs keep reacting the same way. Mercury keeps binding to proteins the same way. Dust keeps scarring tissue the same way. Physics and chemistry do not get tired of being right. And speaking of being right, there is another detail about Mercury's environmental journey that feels almost like an insult. Even when emissions stop, mercury already deposited can be re-released. Soil can emit mercury back into the air under certain conditions. Disturbance of sediments can mobilize mercury again. Wildfires can release mercury stored in vegetation and soil. So the cycle has memory. The Earth keeps receipts. That is why remediation is hard. Cleaning up contamination is not just removing a visible source. It is dealing with a substance that has spread into complex systems. Sometimes remediation involves removing contaminated soil. Sometimes it involves capping sediments, isolating them. Sometimes it involves changing conditions, so methylation is less likely. Sometimes it involves advising people not to eat certain fish. Often, it involves a combination. Always, it involves compromise. And compromise is the human way of living in a world that does not reset itself neatly. So, as you continue following this thread, you find yourself drifting toward the quieter side of the story. Not the chemistry this time, but the human habit of work itself. What it means to spend your body on a task. The miner's day begins before the mine. It begins with the small chores that make work possible. Eating, finding clean clothes, or the closest thing to clean, checking tools, walking to the site. The mine is a community as much as a workplace. People share gossip, advice, superstition. They share techniques for dealing with heat and dust. They share tricks, like wetting a cloth to cover the mouth, even if it does not stop vapor. They do what humans always do, which is create informal solutions before formal ones exist. Some of those tricks help. Some are placebo. Placebo is not useless, by the way. It can reduce stress, and stress is its own exposure. But placebo does not filter mercury vapor. So you have this tension between what feels protective and what is protective. The cloth feels like armor. The vapor slips through anyway. The same tension shows up in many areas of life. Humans love rituals, and rituals are not always wrong. They are just not always sufficient. This is where you, as the cynical time-traveling guide, have to admit a small, grudging respect. People did the best they could with what they had. They made meaning and routine in a place that was fundamentally hostile. And sometimes, that meaning was the only thing that made the shift bearable. So the miner goes down again, day after day. The mine becomes familiar. The dangers become predictable. That predictability reduces fear, but not risk. Over years, the miner ages in a specific way, not just wrinkles and gray hair, but the posture of someone who has spent too much time stooped. The shoulder tension from swinging tools, the deep fatigue from heat and low oxygen in some passages, the cough that becomes a companion. If mercury exposure is significant, maybe the tremor appears. Maybe mood changes. Maybe memory dulls. Maybe sleep becomes restless. And because this is a town, not a lab, people interpret what they see through social lenses. They whisper, they joke, they avoid, they sympathize, they invent nicknames. The person becomes a story. Only later does the story become data. And now, with all these threads gathered, air measurement, bodily repair, dust accumulation, environmental cycling, you are ready to move into the broader reflection that the outline has been quietly preparing. Not a conclusion, not yet. Just a shift in focus. Because after you follow Mercury through mines and lakes and instruments, you start noticing that Mercury is not unique. The pattern is the point. Humans extract. Humans concentrate. Humans inhale and ingest what the planet kept dispersed. Humans learn, late, that concentration changes everything. A trace element in rock is not a daily hazard. A trace element turned into a vapor in an enclosed tunnel is. A mineral in sediment is not necessarily a problem. A mineral transformed into a bioaccumulating form in a food web can be. The mine, in this sense, is a machine for concentrating nature's scattered ingredients into human-scale trouble. And once you see that, you begin to recognize the same machine elsewhere. Lead in paint and pipes, asbestos in insulation, arsenic and pesticides in groundwater, radon in basements, different elements, same basic plot, invisible, slow, and finally undeniable. So your mind, still sitting with the miner, starts to drift outward toward the human habit of working too hard in places never meant for bodies like ours, and toward the quieter, almost domestic question of what